Okay. For this 500-foot amount of fencing, that's your perimeter. You want to make a pig pen or horse corral. One side's a barn. Find the maximum area. So what we're trying to maximize is area. Area is going to be x times y. By the way, here's the barn. Here's a rectangular pen. This is x, this is y. Area would be x times y. You're maximizing this. We need a secondary because we need these x's and y's to disappear. We need to have all x's or all y's. The secondary equation is perimeter. What does my perimeter equal? 500. What do all the sides? Well, aren't the sides 2x plus y equals 500? I have 2 x's and a y. It should add up to 500. Now, in order to get this into one variable, what variable do you want to change this? I probably want to get y by itself. Wouldn't that be the easiest, prettiest? If I got x by itself, I want to get some fractions. So I'm going to take this minus the 2x over. It's pretty important that you kind of think about which one's easier. You're going to take this, and where are you going to plug it in your primary? In for y. Now you have x times 500 minus 2x. That is my new equation. This equation relates to the information here. This is your secondary, this is your primary. I want to derive this to maximize. So, a prime is going to be, before we do that, let's distribute this. What do you get? Doesn't that become 500x minus 2x squared? We okay with that? So a prime is going to be 500 minus 4x. If I set this equal to 0, because that's critical numbers, you end up with x equals 125. So that is saying my answer is 125, but we have to make sure that's a maximum. Now, to make sure it's a maximum, we need to find a double prime. What's a double prime? -4. Doesn't that mean for the whole entire graph it's concave down? Doesn't matter what you plug in, it's concave down. So, doesn't that guarantee that this is actually a max? The whole thing's concave down. Won't that critical number actually be a maximum? By the way, look at this equation. Isn't that an upside down parabola? Don't you know an upside down parabola will have a maximum? You could also look at it that way. So we know this is its max, but that's not the answer. By the way, what if your answer came out to be like 700? Is that possible? No, because when you went and plugged it in here, wouldn't you get like too much fencing for one side than you even have? So these answers, they can't be negative because you're talking about fencing. They can't be bigger than 500 because you only have 500. Keep track of those kind of things. Sometimes you get answers that don't make any sense. Okay, does this answer make sense? Does that one make sense? Yes. How do we find out y? Which of these two do we plug it into? I would plug it into this one. Okay. Actually, do we even want y? What is it asking for? Area. Can I just plug it right here? You guys see that? Your new equation, can't you just go plug it in there and find your maximum area? Or could you plug it in here, then go back and plug it in here? And when you do all this math, what do you get for your area? 31,000? 250. Now, it is what dimension? Feet. And if it's area, isn't that square? It's pretty important to get used to these dimensions. That would be the maximum